Hello students, we have studied enough of relations and functions. Now today we will be studying about binary operations. Binary operations are not new to us. From the very elementary classes we have been studying many operations such as addition, subtraction, multiplication, division, etc. The entire mathematics is full of binary operations. Today we study it in a formal way. What is a binary operation? A binary operation is just a function from the set A cross A to A. So, it is merely a function whose domain is A cross A and codomain is A. For instance, we have a set A, suppose 1, 2, 3, 4, 5. We define operation star by A star B is A plus B. Then we have 1 star 1 is 2, 1 star 2 is 3, 1 star 4 is 5, but 1 star 5 we have no element in the set A. So, this is not an example of binary operation, because this rule does not make it a function. In short, always the output of the binary operation must be in the set. So, for this set, this is not a binary operation, but with slight modification we can make it binary. Suppose our set B is set of all integers. In this case, the same operation A star B, A plus B does make a binary operation, because in this case the output of the two elements is ultimately a member of this set B. So, essentially for any binary operation the output has got to be inside the set. Binary operation is called commutative if the elements can be interchanged. For instance, suppose the operation star is defined in A. So, this is called commutative if A operation B is B operation A for all A and B belonging to A. For instance, our usual operation of addition of numbers is commutative. Similarly, the operation multiplication is also commutative, whereas the operation subtraction defined on integers is not commutative, because A minus B is never equal to B minus A unless A and B are equal. So, we have example of a binary operation which is commutative. Similarly, the operation division on non-zero real numbers is also not commutative, because A upon B will not be equal to B upon A unless A and B are equal. There is one more kind of operation called associative. A binary operation star defined on a set A is called associative. If A star B star C is equal to A star B star C. Look here, the bracket is first with A and B. In the second case it is B and C. If both of these give same result, we say the operation is associative. Our operations usually addition and multiplication, they follow this law, but even in life this law is not always followed. A binary operation is called commutative. We have a binary operation star defined in a set A is called commutative if A star B is equal to B star A for all A B belonging to A. Our usual operations addition and multiplication follows it clearly, because we have A plus B is B plus A as well as A B is equal to B A. But A minus B is not B minus A and A upon B is not B upon A. Even in life also, at times this law fails. For instance, you write the word akalmand. If you reverse it, it becomes mandakal. They are not equal. Similarly, setup is not equal to upset. It means whenever reversing the two elements in operation makes no difference, the operation is called commutative. Otherwise, it is not commutative. One more type is associative. A binary operation star defined on a set A is called associative if A star B star C is equal to A star B star C. You may notice here, in the first case the bracket is with A and B, whereas in the second case the bracket is with B and C. Why it happens? Because essentially binary operation is between two elements, but when there are more elements we have to take two at a time. Now, which two at a time, which two first is the case. Sometimes it makes a difference, sometimes it does not make a difference. Whenever the grouping of these elements makes no difference, we call it associative, otherwise it is non-associative. Interestingly, our usual operation of addition and multiplication follow this rule, because in case of 1 plus 2 plus 3 is always 1 plus 2 plus 3. Similarly, 1 times 2 times 3 is 1 times 2 times 3. But A minus B minus C is not equal to A minus B minus C. Similarly, A upon B upon C is not equal to A upon B upon C. In fact, in life there are instances where this law fails. For instance, if somebody has taken your pocket and running away, you want to say that roko mat jane do, but you said roko mat jane do. Now, although same words are there, order is same, but the punctuation make a difference. Here the punctuation marks take the role of brackets. So, roko mat jane means stop him, do not let him go, whereas this means do not stop him, let him go. So, this kind of thing is possible even in life. So, we have to be very careful. In fact, a language teacher while teaching punctuation mark can use this concept as a caution, saying that in any sentence the arrangement of words is not associative. This makes the importance of punctuation mark in a sentence. Now, let us take a problem. We are given a set 1, 2, 3, 4, 5 and a binary operation is defined as A operation B is the minimum of A and B. We are required to write the operation table. By an operation table we mean writing all the outputs of all possible outcomes in a tabular form. Here we make a table. There are 5 elements. So, the operation table is just the depicting of all the outputs of the operation for all possible cases. Here we have 5 elements. So, we make a column of 6 by 6 array. We first write the elements at the top 1, 2, 3, 4, 5, again 1, 2, 3, 4, 5. Now, in the first cell, that is underneath 1 and 1, we get 1 star 1. 1 star 1 is minimum of 1 is 1. Here 1 star 2, that is 1, 1 star 3 is 1, 1 star 4 is 1, 1 star 5 is 1, because between 1 and 5, 1 is the minimum. Similarly, 2 star 1 is again 1, 2 star 1 is 2 star 2 is 2, 2 star 3 is 2, 2 star 4 is 2, 2 star 5 is 2. 3 star 1 is 1, 3 star 2 is 2, then it is 3, again 3, again 3. Here 4 star 1 is 1, then again 2, 3, 4, 4. Here we have 1, 2, 3, 4, 5. Now, this table gives the output of any 2 elements operated. Supposing we want 3 star 5, we go to the column number 3 and row number 3 and column number 5, we get 3. So, by making an operation table, we can always find out A star B for any value of A and B. Now, the table is useful only when the number of items are finite and small in number. Let us take the next problem. Here a set is given containing 1, 2, 3, 4, 5, and a rule is given that A star B is LCM of A and B. Now, the question is whether with this rule does it define a binary operation. In any case, we have to justify our answer, maybe yes or no. Please recall, we were insisting that the output of an operation should belong to the set, otherwise it will not be binary operation. Here A star B is LCM of A and B. So, we have 1 star 2 is 2, 1 star 1 is 1, 1 star 3 is 3, 1 star 4 is 4, 1 star 5 is 5. So far we have no problem. But as soon as we go for 3 star 4, this is 12, because LCM of 3 and 4 is 12, but 12 does not belong to the given set. That is enough to say that it is not a binary operation. So, even it fails for one case, it cannot qualify to be a binary operation. So, the answer to the question is it is not a binary operation, because there are 2 elements, namely 3 and 4, whose output is not in the set. As such, it is not a function from A cross A to A itself. Our next question is to determine among the given operations which are commutative or associative. We are given 2 operations. First is A star B is 1 for all A B belonging to R. Let us take first case for A. First we test commutative. A star B is 1. In fact, always the output is 1. So, B star A is also 1. Thus, A star B is equal to B star A in general. So, it is commutative. To show that it is associative, let us take first A star B star C, that is 1 star C, that is 1, whereas A star B star C is equal to A star 1, that is again 1. Thus, we have seen that A star B star C is equal to A star B star C. So, it is associative. This completes the first part. For second part, we have A star B is A plus B by 2. Now, we have A star B is A plus B by 2, while B star A is B plus A by 2, the same as A plus B by 2, and hence A star B is B star A. So, this is commutative. Let us take next property, A star B star C. This is A plus B plus C by 2 whole by 2, that is 2A plus B plus C by 4, while A star B star C is equal to A plus B by 2 plus C whole by 2, that makes it A plus B plus 2C by 4. Thus, we see that A star B star C is not equal to A star B star C. So, it is not associative. Dear students, today we discuss about binary operations. We classified the operations into associative and commutative. We discuss many examples and counterexamples, not only from mathematics, also from life. In our next episode, we shall discuss some more problems and some more notions involving binary operations.